All right, here's a couple of problems that are Chapter 6 review problems for the Benchmark 6, or it's Chapter 6 but Benchmark 7 test. This first one, we could rewrite this, letter B here, as the integral of 1 over 5x plus 1. That might help some of you see how to do this. Any idea what you're going to use to do the integral of this? Natural log. Yep. This is like a 1 over u. My u is 5x plus 1. So what's the derivative of 5x plus 1? It would be 5 and then dx. So I need to put a 5 in here to do this problem, which means I have to put a 1/5 out front. So this would be my du. That's what's going to drop off the problem. So when I do the integral, I'm going to get 1/5 times what? 5x plus 1, right? Just putting absolute values there because we know that this cannot, you can't take the natural log of 0 and you can't take the natural log of a negative. But we're going to get a positive value anyway. I can see that when we plug in 0 and 4. So we're going from 0 to 4 again. Now this 1/5, you can either multiply everything, you can leave the 1/5 in the expression, or you can leave it outside the expression and multiply by 1/5 at the end, which is what I'm going to do. So you're going to have 1/5, plug in 4, so 5 times 4 would be 20 plus 1. So you're going to have the natural log of 21. You don't really need absolute values because 21 is positive. If you put the absolute values on there, that would be okay. But plug in 0 would be the natural log of 1. Anyone know what natural log of 1 equals? It's 0, because remember, you're thinking e to what power would give me 1? Logarithms always equal exponents, so e to the 0 would equal 1. So this right here is equal to 0. So our final answer would be 1/5 times the natural log of 21, because subtracting 0, you don't need to put that down. Any questions on that one? All right, letter E. Similar but different. The big difference here is that the expression in the bottom is not to the first power, it's to the third power. So what I want to do here is just move that to the numerator and call that x minus 4 to the negative 3. You will not need logarithms to do this problem. You only use logarithms when your expression in the denominator is to the first power. When this whole expression here is to the first power. When it's to the third power, you don't need to use logarithms. We're going to make this expression, this exponent 1 bigger. So that's going to be x minus 4 to the negative 2. What would I put out front?
Negative 3. Or negative half.
Negative half, yep. You take, this is a 1 here, so 1 divided by negative 2, negative 1/2. And we're evaluating from negative 1 to 2. So if we put in 2 first, you're going to have negative 1/2. Let's just take negative 1/2 times our final answer. Oh, you know what? Let's rewrite this. I don't like to try to plug numbers in when there's a negative exponent. Let's rewrite this as negative 1/2 times 1 over x minus 4 to the positive 2. If you move this back to the bottom, you can call it positive 2. You could multiply by half right now, but I'm just going to wait and multiply by the negative 1/2 later. I just think people make less mistakes when they get it changed back to positive exponents. So you're going to have negative 1/2 times, plug a 2 in here, so 2 minus 4 is negative 2 squared. What's negative 2 squared? 4. So you can get 1/4 minus, now plug negative 1 in there. Negative 1 minus 4, that's negative 5. Squared would be 25. Let's try to simplify. Let's change everything. Let's see, the common denominator for 4 and 25. What would that be?
150. No, 100.
75.
I think we got to go with 100. A fourth is how many hundredths?
How do you get that 75?
25.
How do I get what? Oh, okay.
No, I'm talking
Yeah,
about
1/4 is 25 hundredths. 1/25, taking both times 4, that's 4 hundredths. Little fractions here. Let's bring this up so we can see a little better. 25 minus 4, that's 21 hundredths. Multiply by 2, you get, on the bottom, you get 200 in the denominator. Numerator, you get negative 21. That's our final answer, negative 21 over 200. Any Any questions about that one? All right, let's keep going.